Hey guys, today I want to walk you through some logarithmic equations that we're going to solve that already have the word logarithm in them somewhere, either twice or once or 3 times or however many times. But the last time we visited, we had equations that we were in exponential form that we use logarithmic form to solve. This time they're already going to be logarithmic form, so guess how we're going to solve them? Yep, exponential form. Okay, so let's start off with this one right here. A lot of times people think this one's really tough because it has 2 natural logs in it, one on each side. Now there is this really convoluted way you can do this problem by subtracting this from both sides and then condensing it and then putting in exponential form and then solving it from there. But that's really rather silly, because if the natural log of this equals the natural log of this, shouldn't these 2 things equal each other? We can go straight to 4x minus 7 equals x plus 5 and solve that. That doesn't have anything to do with logs or with exponents. But the fact is, we can get the correct answer this way without even having to use logs or exponents, because of the fact we know that the natural log of this argument equals the natural log of this argument, so these 2 arguments should equal each other. Okay? I'll go ahead and follow through with this solving so you can see. 3x equals 12, so dividing both sides by 3, x equals 4. Okay? Now when I go to check this answer, which is what we always like to do just to make sure our work is correct, we say 4 times 4 is 16, minus 7 is 9. Now I don't know what the natural log of 9 is, and at this point it doesn't matter, the natural log of 9. Because when over here I get 4 plus 5, and that is the natural log of 9. And what's important to know is that the natural log of 9 does equal natural log of 9, so I know that this is the correct answer with confidence. Okay? Now, there's 2 ways to solve this problem. I'm going to show you both ways. I think one way is easier compared to the others, but again, I'm going to show you both ways so you've seen both ways so you can make your own decision. Okay? The first way we can solve this is by noticing that this has log base 2 of 5x minus 17 equals 3. That's just basic logarithmic form. Okay? We could just take this from logarithmic form straight to exponential form, which would be base is the base, answer is the exponent, and that should equal the argument. Remember that when we're going back and forth about how to put stuff from logarithmic to exponential and back and forth, and I told you that was important? Well, this is why, because we're going to be able to solve equations with it. So 2 to the 3rd power, we know that that's 8. 8 equals 5x minus 17. Well, that's just a simple equation to solve. If I add 17 to both sides, I get 25 equals 5x. If I divide both sides by 5, I get x equals 5. Okay? Again, we want to plug in the answer to make sure that we know we have this correct. So we can say there's 2 ways, just reminding you that about this also when you're checking answers. Okay? I can say log base 2 of 5, not down there, 5, oh, I put an extra parenthesis in there, sorry about that, 5 times 5 minus 17, and just hit enter, and it tells me 3. Okay? Or remember, I could put log base 2 of 5 times 5 minus 17 equals, not there, 17, equals 3, and then hit enter. Well, it tells me it's false. I wonder why it tells me it's false. Because it just told me it was true right up there. So how about we just don't do that way for right now? I don't know why it's doing that. Maybe I didn't put an extra set of parentheses or something. So let's just ignore that way. We're just going to pretend I didn't show you that way. Okay? Plug it in. Make sure it equals 3. It does equal 3. I don't know why it's being weird. Okay? Either way, we know that 5 is the correct answer. Okay? But there is another way to solve this problem. Okay? The other way that we go about solving this problem is something called exponentiating. Now, that's the technical term. If you look in your book, if you look in the help section of your online textbook, it's going to talk about exponentiating. So that's why I'm showing you this way, because if you go to look for help, if you're struggling with things like this, you go to look for help, that's the word that it's going to use. And so I want to make sure you understand what's happening. Okay. So here's our problem. Okay. The way we exponentiate is we look at the base of the log. Okay. Whatever the base of the log is, in this particular case, it's 2. Whatever the base of the log is, that's what I'm going to use as my base. So I say 2 raised to the power of this side and 2 raised to the power of this side. So what it looks like is 2 raised to the power of log base 2 of 5x minus 17 equals 2 raised to the power of 3. Okay? Now remember our shortcut that if our bases are the same, the answer is just what's left. The bases are the same, so I just get 5x minus 17 as this side. And then this other side is just 2 to the third. That equals 8. Okay? Well, isn't that exactly what I have here in this step over here? All I did over here was just write this in exponential form, which is something we've done and we're familiar with, okay? I'm not saying exponentiating is harder. It just kind of looks harder sometimes. And this is something we already know how to do. However, this is the way the book is going to show you how to do it, so I wanted you to have seen it before, okay? I'm going to go ahead and finish this so that you can see that we get the same answer no matter which way we do it. I get x equals 5. Okay, again, if I plug 5 back in here, I'm going to get, well, think about it this way. That's 25 minus 17, that's 8. So I have log base 2 of 8 equals 3. 2 to the third power equals 8. So I know that 5 is the correct answer. Okay, so there's 2 or 3 different ways to check your answer. One way I did in my head, one way I did in the calculator, and either way the answer is 5. Okay, this way, the way I showed you here, is taking the problem that's written and just writing it straight in exponential form, which you can do because there's only one log in the problem. Okay, this way, again, only one log in the problem. We exponentiated to whatever the base of the logarithm was. I raised both sides as powers of the base of 2. Solved it that way. Okay, so one more example, and it's going to combine several of the things that we've talked about lately. Okay, the quote-unquote problem that people see when they first start this particular problem is the fact that it has log twice. Well, that shouldn't be a problem to you because the last couple assignments we did something called condensing. We know that if we're going to condense this side, we only want log written one time, which is what we want if we're going to solve these logarithmic problems. We only want log written once if possible. Okay, unless it's on the opposite sides of the equal sign, but we don't care about that right now. Okay, so log, I'm going to condense this left-hand side of the equation so that log is only written once. What does this sign mean when we're condensing? It means multiply. I know very well that it's a plus sign, and that typically means add. But remember, when we're condensing, a plus sign tells us to multiply these two terms. So I have 2x times x minus 5. And that just equals 2. Okay? I'm going to go ahead and put that in parentheses as well for now. Now, I do want to simplify that because I don't want to leave that like that because it's kind of messy. So I want to write log of 2x squared by distributing that here and here minus 10x equals 2. Okay? So I have two choices now. I can either put it in exponential form like I did on this problem right here, or I could exponentiate, which I did on this one right here. Either one is correct, whichever way that you feel is more conducive to your way of learning is fine with me. Okay, I'm going to show you both ways so you can make sure you understand both ways. Okay, so if I'm going to write this in exponential form, what's the base of this log? Well, nothing's written, is it? So what is it automatically? Good, 10. 10 to the second power equals the argument, 2x squared minus 10x. Okay? Well, what is 10 squared? We could simplify that. That's 100. 100 equals 2x squared minus 10x. So how do we go about solving this problem? Well, what type of problem is it? When a squared shows up, I know it's a quadratic. So I know I want to get it equal to 0 because there's an x squared and an x term. I want to get it equal to 0. So I'm going to go ahead and subtract 100 from both sides. So 0 equals 2x squared minus 10x minus 100. So you know 5 ways, I think, to solve a problem from this point. Hopefully you remember the first thing that you want to do, no matter which way you choose to solve it, is try to take out a greatest common factor if that's a possibility. Noticing that every single one of these terms is divisible by 2, let's go ahead and divide every single term by 2. Okay? When I do that, I get x squared minus 5x minus 50. Okay? Now, for those of you who are even decent at factoring, hopefully you can see right off the top of your head that 50 is 5 times 10. And I can definitely use a 5 and a 10 because it's got to be, one of them has to be a negative to get a negative 5. If not, you could definitely graph it. You could definitely use quadratic formula. You could use completing the square if you wanted to. Okay, but factoring at this point is probably the most efficient. So x minus 10 and x plus 5 would be my two factors of here. Knowing the zero product property means if these two numbers are being multiplied together and I get an answer of 0, one of these has to be 0. I don't know which one it is, so I think both of them are. One or the other. Okay, so I set each one of them equal to 0 and solve each one of them. So which one's right? Well, I have to check, don't I? Okay, so I have x equals 10 and x equals negative 5. So I go back, way back up to the original problem. And I've got to check 10 and I've got to check negative 5. Okay, so let's check 10 first. Let's see. That's not what I wanted to do. Let's just get a new document. That's easier. Log of 2 times 10. Excuse me. Log base 10. Now I don't have to put the base in if I don't want to, because I know that it's base 10 because there's no base written, of 2 times 10 plus log of 10 base 10 of 10 minus 5. And I know that that answer should be 2 if I got it correct, and I did. So I know that x equals 10 is an answer. It is correct. Now I need to check the other one just to make sure. Okay, x equals negative 5. So, log of base 10. I'm just not going to put a base this time, and you'll see what happens if you don't already know. That's okay. 2 times negative 5 plus log of negative 5 minus 5. Uh-oh. Something happened this time. What happened this time? Well, this time it says it's not real. Okay? So even though I got 2 answers, this one doesn't work. All right? So x equals 10 is our correct answer. Okay? Now, let me show you something real quick. Exponentiate. What happens if we exponentiate that side instead? If we take this problem from where it is and we exponentiate? Well, what's the base? I'm going to go ahead and put this in parentheses so we don't get confused. Okay? The base of this log is 10, so I would say 10 to the log of 2x squared minus 10x equals 10 squared. So it's 10 raised to that side and 10 raised to that side. Okay? Log base 10 of 10, when the base and the base are the same, the answer is what's left? 2x squared minus 10x equals 100. Well, that looks terribly familiar to this step right here. Okay? I'm not going to finish this out because you know we're going to get exactly the same thing because that's exactly the same thing right here. Okay, so once you condense in problems where you have logarithm written more than once, once you condense, you can either write it in exponential form or exponentiate, whichever way you're more comfortable with. Okay,